Because you indicated that you had some questions on the weighted averages, I wanted to go through 1 and 3 with you. Actually, 1 with you completely, and then 3 I'll just get you set up and you can try and calculate that one on your own. But what we need to do is separate the weight from the actual score that they earned. In this case, it's I always think it's easy to really look at it when you're talking about percentages for a class, but there are other styles of weighted averages as well. And the second one on problem number 3 that we do, it will be not a score for a class, but it'll be a percentage of moisture or water that remains in a whatever scientific kind of setting where they're testing water in the earth. Anyways, let's focus on this one. So they're going to give us 2 pieces of information. One that is what the weight is, and the weight is basically how much it's worth. So a lab is worth 25%, so I put 25 down for the weight for the lab. The tests are 22.5, so I put that down for the weight for the test. Because there were 2 tests taken, both of those are going to be using that value. And then the final exam is worth 30%. And so when I add this all up, I should end up with some sort of value, and oftentimes it is, especially in the school setting, it should equal 100, but that's not always the case. It doesn't always have to be 100%. But this would be, 45, 75, yeah, so this comes out to be 100, and that's what this is about. This means sum. Whenever you see this symbol, that means whatever I'm looking at, I want to add up that column. So then when I go to the score, I'll put in the lab score, and that comes later on. So the following, got a 92 on that first lab, 81 on the first major exam or major test, 93 on the second one, and then an 85 on the final. And so what I need to do is do the weight score combination. So my next column is weight times score combination. And so I just take a calculator and figure those out. So I need to get into a mode that I can do that. So I do 25 times 92, get that value. 22.5 times 81. 22.5 times 93. And 30 times 85. Okay, up next is to find that sum, because what I need is the sum of the weight score divided by the sum of the weight. So the sum of the weight score then is 2300 plus 1822.5 plus 2092.5 plus 2550, and I got a weight score total of 8765. To figure out my weighted average, I would do that 8765 divided by the sum of the weights, 100. So divide by 100, and my final answer is 87.65. So 87.65% is what this biology class grade would be in this specific scenario. So again, the formula that you're really looking at here is the sum of the weight score divided by the sum of the weight. And so sometimes the most difficult part is making the little table. So I want to get you started with your table on the next one. And this one I went through and I highlighted. They start by giving me the weight. So again, this is an Environmental Protection Agency and wetland environment, and They're wondering where does the water go, and so 38% of the water is outflow, so that flows away. Seepage goes into the earth. 7% evaporates, so that gets kind of whatever, sucked up by the air, kind of. I know that's not the scientific term, but, and then 8% will remain there. Okay, so those become our weights, and you have to be a little bit careful, because like in the last one, for that biology class, there were 2 tests. But in this one, there's not going to be 2 pieces of, it's straight that it's these 4 events are it. And so when I put in those weights, it's just those percents. And again, I need the sum of those to use later on, because the sum of the weight is going to be what I'm going to divide by. And so I just add those up. It looks like that's 100 as well. 15. Yep, that comes out to be 100. Okay, then the concentration, and again, the labels of these don't really matter, but it did say compute the weighted average chlorine compound concentration. So then I'll put the concentration here. And so it says in the environment the following concentrations of chloride compounds were found. The outflow was 64.1. The seepage was 75.8. Evaporation was the 23.9. And then the water left was the 68.2. And so again, my next column that I'm going to write is going to be that product of those 2 things. So it's the weight times the value. We can call it X, that's your score. This concentration is my X value, that's the value that's given for that certain thing. So I could just call it in general that. And again, it's going to be calculation. So I'll have you finish this off, because all you need to do is do your weight times X, get those values, get that sum, and then your final is the sum that you get for your WX divided by the sum of your weight. So again, it's the sum of W times X divided by the sum of the weight alone. That will give you your weighted average. All right. So again, give that a try, see how you do. You can pause the video and then turn it back on. I just wanted to practice with you today using the calculator, going through that concept and looking for the things that we need to find. So I did write down some stuff. Again, you can pause and rewind and go back. But when you're ready, I wrote down some stuff that we're going to be looking at. The calculator steps. When you use the calculator, that the graphing calculator, we just have to go into that spreadsheet, and remember when you hit the home screen, it's the, oops, gotta get where it's not a glare, it's the thing that looks like a little spreadsheet. And so you just kind of arrow yourself over to that and select that. That's how you're going to start when you're going to be using the calculator. And the calculator is going to be able to find all things like your mean, your median, your standard deviation that we talked about in class. The variance we'll have to do some calculation with, but it's going to give us a lot of information so we don't have to be plugging stuff in. There are certain things that we won't be able to use the calculator for, but most of them are pretty easy things to work through on your own, like finding the range or the mode, things that are more visual. But anyways, you select your spreadsheet, then you enter your data, and you arrow up. Once all your data is entered, you arrow up the row until it's highlighted, and I'll go through that with you when we enter our new data. Then you're going to select menu, stats, stat calculation, one variable stat. That's the kind of process. So hit menu. In the menu selection, you'll hit stat, statistics. In the statistics selection, stat, statistic calculations, and then one variable. When you hit enter, you'll hit it a couple of times, and then all of a sudden the information will appear to you. Now, before we do that, I'm going to slide down to the bottom of the page because I wanted to define a few things that we're going to be looking for. And so the things that we've talked about up to this point are the mean, which is the average. And if it's a sample mean, we use x bar. If it's a population mean, we use mu, and that's this little thing. The median is just capital M, and that's the middle number. Mode is the most occurring, not on the calculator. You're going to have to look for that one. Range, also not on the calculator. It's biggest minus smallest. So that's also not on the calculator. But it's not a difficult process, okay? Standard deviation, if it's a sample, which they'll indicate to us, if it's a sample, we use the S for the standard deviation. If it's the population, we use the sigma, lowercase sigma value that's listed. Variance, I might have to do this calculation myself. I actually don't remember if it shows up, but if they ask me for the variance for a sample, I would just take the standard deviation and square it. If they ask me for the variance for a population, I take the sigma value and square it, both of which are standard deviation. And then the one we did today as well is the coefficient of variation, and that's where you take your standard deviation divided by your mean. So if it's a sample, it's S divided by X bar times 100. If it is a population, it is the sigma standard deviation divided by mu, again, which is the mean, times 100. Basically, these mean the same thing. It's just a different symbol in stats that indicates whether it's a sample or a population. So now we'll go through that process. And again, we went through the calculation, and like I said, it's putsy and it's all doable, but if we can go into the calculator and do it, why not make our lives that much easier? Because as you said, in the real world, that's typically how you'll do it anyways. When we have one variable, meaning I just have one set of data, I can just enter stuff in. I don't need to save anything or name anything, so I just go through and enter my data. And I'm working right out of the homework packet today, so I'll run through one with you, and then I'll let you kind of try another one on your own, and then, you know, obviously when you come to class again, we can go over any questions. So I have all my data entered, then I'm gonna arrow up until it's highlighted, so I need to get that whole row highlighted, and I have to do that because otherwise the calculator doesn't know which data I'm looking at. So if I highlight the row, then I can hit menu, and I'm going to go to statistics, so that's the fourth selection, so I hit 4, and then stat calculations is the first selection, so I hit 1, and then one variable is the first selection, so I hit 1 there as well. And then again, it just goes through this series of questions. How many lists do I want? I only want one, so I hit enter. It's going to ask me where I want to put the stuff. It's from list A. They're going to put the results in list B. So I just hit enter, and then it'll list all of the information. And so then I can interpret that information. And so X bar is my mean. This is the sum of all my X's. So if I added up 23 plus 17 plus 15 plus 30 plus 25, I would get 110. This is the sum of the X squareds. This is S, so it's my sample standard deviation. As I go down to the next one, I have my sigma, so that would be population standard deviation. So I'm going to have to pick which one I'm going to use depending on whether my data is stated as sample or population. Then I have my sample size, the min value. We'll get into Q1, but the median. We'll get into Q3, that's kind of in our next lesson, and then the max. So I could go, I know the max is 30, especially if I enter a lot of data, I can just look for my max and my min, so my range would be 30 minus 15. And then it gives me some other information. This last one is just another value that we'll use when we get later on. No need naming it right now. But I'm going to go through, and again, it asked me to find my range and the mean, and so I'm going to go back up. Remember, my range is my max minus my min, so this was 30 minus 15, or 15. That's my range. And then the sample mean, my mean is they said it's a sample, so I'll use X bar to represent it. Regardless, the calculator doesn't know if it's a sample or not, so it's going to list it as X bar all the time. But if this were a population mean, I would use mu instead of the X bar. And that's just little things. So this is 22. And then it says, use the defining formulas to compute the sample variance and S squared, or sample variance and the sample standard deviation, but I'm not going to do that. I am just going to use it off the calculator because, again, why not? So it said sample standard deviation, so I use S. So my S equals 6.08276. Yours might have more or less decimals. It depends on what the setting is set for. It doesn't really matter. Usually I would probably just do 6.08. But then my variance is the standard deviation squared. So I just take that value and I'll have to go into the calculation mode and square that. But before I do that, I want to make sure I have everything I need. I need to find the coefficient of variation, and that was the standard deviation, 6.08276, or rounded off, again, divided by x bar, which was 22, times 100. And so now I can go into the other mode. I'm going to hit on and calculate to get my variance, which is S squared. So on this, I'll select A to calculate, and I will do 6.08276 squared. Got a little squared key on here next to the 4. Hit enter, and it will spit out my variance as 37. Okay, so I can get all of those pieces of information from my calculator just by entering that. Again, pause the video if you need to, back up if you want to get all these things down, and then once you're done, I'm going to have you see how you do on the next set. Again, don't worry about the computational formula. Just use the information that's given, find the range, the sample mean, find the standard, the variance and the standard deviation, and find the coefficient of variation. It tells us that this is, again, a sample, so again, you're going to be using X bar and S for your data when you use it. And then when you come to class on the next time we meet, then we'll work through the last section of this, which is going to be making another plot. It's called a box and whisker, and we use those Q numbers in our in that spreadsheet. But just come with questions, and if something's not sitting right, just let me know, and we'll work through it. And I will see you soon.